everyone, welcome back to OneTouchBI. I am Sarunan Vajravel. I have with me another like-minded person who have vast 10 plus years of working experience only on Python data science and deep learning. I am pleased to welcome Mr. Kalyan into OneTouchBI for sharing his knowledge.
Hello everyone, I'm Kalyan. Today I'm going to talk about OpenCV. OpenCV is a Python library basically used for image pre-processing and computer vision. The objective of this tutorial is to extract an object from an image. I'm splitting this tutorial into three parts. The first part is going to talk about, how do you import an image and do certain thresholding, and over to that some adaptive thresholding. What do you mean by adaptive thresholding? And then trying to mask certain area of the image and then trying to extract the image, whichever that is, the object which needs to be extracted. So with that introduction, so I'm just getting into the PPT, which has been what is the primary objective of the study has been put in clear here, right? So we are going to have an input image which is on the plate with a finger into that. Our objective is to extract an object. Here the object is the apple, right? First we need to mask it and then we need to extract it. This is somewhat challenging. Understanding the nitty-gritties of each and every the functions is very critical here. So the approach which we would be taking here is that the first thing is we would be taking an image, trying to convert into a grayscale image, and then do the global thresholding, which is a simple threshold, and an adaptive threshold. So this is the approach which we would be taking for this particular thing. So the global threshold basically trying to see, how you handle using the threshold value based on the intensity. If you see in this image, all the image gets recognized by the machine in the way of numbers, right? When you import, it needs to be recognized as numbers. So here we have various type of thresholding to understand the object, and with the various thresholding technique like binary inverse, truncate to 0 and to inverse of 0. So let's go through one by one. Okay, so having given introduction, let's jump into the code. So for taking object from an image, right? So we would have the following approaches. One is that we'll try to understand what is the global threshold or simple thresholding technique, and then we'll try to use how adaptive thresholding is going to help us, and then we'll try to extract object from an image. So here we are trying to uh, remove the plate and the skin from there, and finally we are going to take apple out of the image. So there are a lot of challenges. We need to apply various techniques to do that. Let's start with taking an image, multiple images into our path. For that, we need to use import of OS, which is an operating system. Okay, let's try to import operating system and then try to see whether where the current working directory is. My current working directory is this particular place where I'm going to store all the images. Then we need to start importing the required libraries, which is the OpenCV libraries, Matplotlib, NumPy, and Pandas. Let's import one by one. Import CV2, import
matplotlib dot pyplot as plt. Okay, next import numpy, right? Numpy as np. Then we need to import pandas as pd, right? Then import matplotlib dot image, sorry, matplotlib dot image as mpimg. Okay, let's try to run this code. What is the issue here? Okay, I have just typed, not given a space here. Let's try to rerun it. What is the issue? Yeah, it's coming good. Okay, so let's start importing the images. Okay, so let's take cv2 and cv2 underscore img is equal to cv2 dot im read. Okay, and try to take apple as an image. Okay, let's take apple image, and we will try to visualize the image. cv2 dot im show. Yeah, so the typing mistakes is cv2 dot imshow. Try to save this image and show this image as apple cv2, which is the image that we need to take it, and then we need to have a cv2 dot wait key function to visualize it. So this is the image that this is the color image that we will be using it. Okay, and we can try even using the same code for the grayscale image. Okay, grayscale image, I'll try to use this as gray. Okay, so the grayscale image, we'll try to use it, and we'll try to run this. What is the issue here? So yeah, I need to make it as gray here also, right? So let's run this code. So you've got a grayscale image here, right? So once you get the grayscale image, now we will start taking this image to the next level. So with regard to the global threshold, basically it tries to apply same threshold value across the images based on the intensity of the existing intensity of the images. Okay, there are various kinds of the operations that can be done. The threshold method is the binary inverse, truncate to 0, and to 0 inverse also. So based on the threshold, we will change the value, right? So let's try to jump into the code. So cv2 threshold is a source, and the threshold value has to be taken max value, the thresholding method. Okay, let's jump into the code. ret rush equal to cv2 dot threshold the cv2 image, right? 70, let's make it as 70 comma 155 comma cv2 rush. Let's use the binary operations. Let's run this code. Okay, now let's try to add more line, because we are trying to see and visualize this. So how do we visualize it? Let's make it as a simple code, and we can start referring this every time. It's just making a list and call this as original image. Okay, and then try to create a binary. Okay, and then we can take the images is equal to, again we will create a list, CV2 grayscale, and we'll take the threshold, right? With this threshold we will be able to see how we can visualize it with the for loop. Let's make it as for I in range 2. Okay, plt dot subplot of 2 comma 3 comma I plus 1. This is a simple for loop which I'm taking it, and then plt dot im show images, right? And then we'll take an I for that, right? So, and this should be a grayscale. Great. Okay. So let's take it as plt dot title, because we have used the images. We need to use a title also for that, right? Let's take titles, and we'll take title. So this should be title, and this should be titles. Okay, titles. Again, we are taking I value and then trying to see plt dot xticks. This xticks will try to remove x-axis and and if you use y-ticks, then it will try to use the y-axis also. Let's try to remove it. Plt dot y-ticks, right? The same way as we have done for x-axis, we have to do for y-axis also. Let's try to run here. So now we got an image, right? So what can be done? Even you can try to add the binary inverse value also by changing it here. So I can just show it to you. For example, let's take it like I'm just copying pasting code so that it can be quick. Let's make it as binary, right? So let's take it this as a binary, sorry, binary inverse. Okay, and here also we can take binary inverse. Let's take it like this, and then let's try to add the thresh. I've not executed this code, so I need to execute it. The thresh 1, here I need to increase the range, right? So when you increase the range, it becomes 3, and then execute the code. Now you got the binary inverse also. Okay, so this is the way that we try to visualize the image. So let's go into contour part. So what is this contour? The contour, the first level is an hierarchy, right? So we need to take an image. There could be one image, there could be multiple image within the image. That's, we call it as an outer hierarchy, parent hierarchy, and child hierarchy. Okay, and what is this contour called? Basically, contour is trying to join all the points having the same color of intensity. Okay, here we can apply the fine contours, and you can apply normal threshold, which is a global threshold, as well as adaptive threshold also. We'll see one by one later. There is a contour retrieval mode also to be given here, where we are trying to see the retrieval points, whether we need to take the parent and child relationship, or only the parent, or only the child, or you need to take with the extreme outer points, so all child contours to be left behind. So you need to take based on the retrieval mode option, and you can try to apply the boundary points. If you give a none, it takes all the boundary points. Okay, and if you give a simple, it takes only the points which is on the corner of the points. The image showed very clearly there, right? This image shows very clearly. Let's try to find the contour of the image. So for that, you need to have a source image, right? And then what sort of retrieval mode is to be given, and what is the approximation method that we will be using it, whether none or simple. These things we would be using it. Okay, let's jump into the code. Contours, comma, hierarchy is equal to cv2 dot find contours, and let's apply only thresh. I'm not applying thresh 1 here. You can try it by your side. cv2 dot retr. Let's try to use only the list part. Okay, and you can also need to take the approximation method, what you're going to take it, right? cv2 dot chain approximation. So let's try to use a simple method here. Okay, and then we'll, after applying the finding the contours, we need to see which is the largest contour. Only then you would be able to extract the plate. So let's try to find out what is the largest areas. Okay, let's take it as sorted, as in trying to sort it out the existing image, and then by taking the contours. Okay, where key is equal to cv2 dot contour area. Contour area. Okay, now you got the largest part of the image, which is the contour of the plate. That's what we are trying to do it. Now we need to draw the contours. Only then you will be able to take only the plate, right? For that we need to apply mask. Let's put mask here. Mask np dot zeros. We'll take cv2 as a grayscale image shape, because we need to use the same shape, correct? And then np dot uint8. Okay, let's try to run this particular code. Now we need to draw the contour, correct? So img underscore contour equal to cv2 dot draw contour, right? Contours. Yeah, let's take this mask, comma. We need to take the largest part of the contour, correct? Let's take it as a list. So here, if you see, the draw contours required image and contour index, the color and the thickness of the contour. So let's take one by one from here. So this one is going to be largest areas, and then we are going to take the big one. So we need to have this -1 here, right? And then we need to have 0. Then you need to take the color of the image. Let's take it like this. 255, 255. Okay, and then we need to take it as -1, the thickness. You can change it whichever the way that you want. Okay, now you got the image with the the largest contour. Let's try to visualize whether we could able to extract only the plate. For that, I'll try to use the same code to save the time. Okay, let me take the same code. I'm going to use the same code. Okay, let's me change this particular part as a, so let's take as a um masked, let's take it as masked image. Okay, where you're going to have only the plate, and then let visualize it only the image contour. Image contour. All the other portion remains the same. Let's see whether we could able to get it. Why we are getting range? Yeah, we have only 2 images going to be shown, so let's change it to 2. Hope you're all clear now. Now we have taken only the image where you have only the plate of it. So we have already seen global thresholding. So let's get into the adaptive thresholding. Adaptive thresholding is going to be very similar, except one is that we are going to apply the thresholding technique based on the smaller region. Okay, that's only the difference. For that, we will be using the mean approach or the Gaussian approach. The adaptive threshold is we need to take a input image and you need to define the max value. The adaptive method, threshold type and block size. Block size is a smaller region. C is a constant. So let's start using that. Adapt fresh is equal to CV2 dot adaptive threshold, and we'll take CV2 image and let's take 100 as a value. Okay, and then we'll try to take it as CV2 dot adaptive. Let's try to use Gaussian technique and CV2 dot thrush. We'll use again the binary operation of it, and then the smaller region let's take as 15, and then we'll try to apply the constant as 2. Okay, let's try to add one more and then try to visualize it. So for that, let's try to use the same code which I've already typed. I'll just copy paste it to save the time. Okay, this is a adaptive masked image. Okay, and let's copy this and then put it here. All the other things are going to be the same. Okay, so here we are going to apply again the contour. Okay, so for the contour we'll try to use the same code what we have used for the global thresholding. Okay, let me try to use the same code finding contours. Okay, so here I need to change the image as adaptive threshold. All the other things are going to be the same. Okay, so then I will start applying the finding out the largest area of the plate. So let's try to apply that. So similar to global thresholding, we are going to apply draw contours also. Let's take the same image, grayscale image, right? Copying it here, running it out, and then finally trying to apply the draw contours. Right? So let me apply draw contours. So it's going to be the same. So I'm going to take it like this. Then let's start visualizing the image. I'm going to use the same kind of thing. Copy paste. Okay, sorry, I should have put adaptive. Okay, as all the other things are remains same, let's take this as a image contour itself. Okay, now we got the plate as we have done for global thresholding. We got with the adaptive thresholding also. Now let's start extracting the object with bitwise operations. Let's use matplot image for that. Okay, plt underscore img is equal to mp img dot im read. Let's take the same image apple dot jpg. Okay, plt dot plot plt dot plot. Okay, and plt dot im show, and let's take plt img. Okay, and let's take it as plt dot title. Let's give a title as original image. Okay, and then we'll try to use the same trying to see the the x-axis, removing x-axis from y-axis from here. Okay, now you could able to see the image. Let's see how we can actually remove the mask, finger and the fruit. This we would be using as the bitwise operation. The bitwise operation basically trying to manipulate and extract the essential part of it. So the essential part as a first step, we will be removing one by one. The first is a apple, the second is a finger, and the third one which we require is an apple. That is the step that we would be going ahead. Okay, let's try to apply the bitwise operation. So img underscore bit contour cv2 dot bitwise. Let's use R. Okay, so the PLT is going to be, you need to have a source image and source image. Here we are going to use let's use as a PLT dot img, and again plt.img. We are going to take the same image and then we are going to do the masking. So we have already done the masking earlier for bitwise contour. We'll use the same mask here. Mask. Let's try to run this. Then we need to find out HSV. HSV is hue, saturation and value. Based on the color and grayness and brightness, we will be able to use and apply the range of it, and that's objective of it, right? So let's try to use HSV underscore img is equal to cv2 dot cvt color. Okay, img underscore big contour, right? That's a bitwise contour that we've already taken it, and then let me apply bcv2 dot color underscore bgr, because this is a bgr. OpenCV uses bgr format. Let's try to change it to hsv. Okay, let's try to run this, and then we'll apply the range function. It is very similar to thresholding, global thresholding and adaptive thresholding, but here we are going to define the lower range and upper range. Okay, so let's try to mask using mask plate. Let's try to use cv2 dot in range function. Okay, and we are going to take HSV image, np dot array. Okay, and then let's define a value for that. So let's take various values, 0 comma 0 comma 50, and then let's make it again np dot array. Okay, np dot array of 200 comma 90 comma 250. Okay, this is a mask we are going to apply using the range function, and then we'll try to copy the same code. Let's see how the image looks like. Okay, let's try to make it. Let's make it as, let's visualize each and every part. One is at the big contour, right? Contour, and let's take one more as masked plate. Okay, here the mask plate should be the one, and we need to change the image big contour. Let's view this also here. Okay, let's try. How does it look like? Now you could see why the third one is not coming. Yeah, we need to change the range, right? Because we have three images. Now, some masked plate has come now. Okay, having got the masked plate, let's try to take the fruit and finger out of the image. So for that, let's take mask not plate. Okay, and we will apply again bitwise operation, but this time we'll use not function and then mask plate, which was a earlier one, right? Again, we'll try to mask underscore mask underscore fruit and underscore finger is equal to cv2 dot bitwise. Let's use and okay, and here I'm going to use image bit contour, and then again same image I'm going to apply bit contour, then mask is equal to mask not plate. Let's try to run this. Okay, and then again try to visualize the same image. So here we have masked plate which we have already taken. Now we need to show the finger. Okay, let's try to add this finger underscore fruit. So what needs to be taken here? Image mask not plate has to be taken and then visualize it as a first step, and then image fruit finger. Let's see whether we could able to remove the finger and apple. Now you could see apple and finger has been removed from the original image. So by masking, we need to actually get only the background. That's our the next objective. Let's try to use the HSV image, HSV CV2 dot CVT color, again mask fruit finger, and then CV2 dot color underscore BGR HSV BGR to HSV. Okay, now let's try to use the in range function here for removing the skin. So let's do cv2 dot in range. Okay, in range, and then take this hsv image and np dot array. Okay, let's try to create using this 10,60, and then let's create np dot array. Okay, let's make it as 2150, 255. Okay, and then let's try not skin. So we have to remove the skin also. We have to find the skin and then remove the skin also, right? Let's do that. cv2 dot bitwise. Let's use not operation. Okay, and then take the skin. Now let's try to use the same code for visualizing it. So this has to be background, right? What needs to be the background? Okay. So not skin or basically it's a background which we will be getting out of that. We are getting an error. So what is the error here? Yeah. So here I have not closed it. Okay, why? So I need to remove the range because we have only two images. Okay, this is the background that we will be using, okay, for extracting the image. So as a next step, we would be trying to have the background and then have only fruit and finger. Let's see how we can do that. Let's take fruit, okay, and then cv2 dot, again bitwise operation we would be using it, bitwise and then mask fruit finger, comma mask fruit finger, comma mask. Let's try to use a not skin, whatever the earlier one that we have defined, okay, which is actually the background. Okay, so let's try to use the fruit background, fruit with the background. Okay, cv2 dot cvt color, and then again have fruit, come on, cv2 dot color, color underscore bgr to gray. Let's try to use this particular part. Okay, and then apply fruit underscore finger, cv2 dot in range. Let's try to use this in range function, and then fruit bw, okay, and then trying to apply this in range the value, right, min and max. So 10 to 255. Let's run this code. Okay, let's again visualize it. So fruit finger. Okay, so all the other things are remains to be the same. Let's take this fruit finger part and then try to see whether we could able to visualize it. Now if you see, we have got fruit and finger which has been masked. Okay, now let's try to remove the finger, okay, from the above image. So for that, let's try to use some adaptive thresholding. Okay, adaptive thresholding techniques, right? So as like earlier, we'll just try to take an image with the thresholding, okay, and then we'll take let's try to use cv2 dot adaptive threshold of the above image, which is a fruit finger. Let's take this and then try to take this fruit finger, and let's take as 255 comma cv2 dot adaptive threshold Gaussian, cv2 dot thresh. Okay, thresh let's take as binary comma 11 and 2. This is as like our earlier steps. Let's execute this. Okay, now we'll try to do the contour exactly with the same approach what we have seen, what we have done before. Okay, so let's try to find the contours, and then there will be a hierarchy here. Hierarchy equal to CV2 dot find contours CV2 dot contours of, let's take this particular image. For this only we are trying to find a contour, correct? So let's take it as CV2 dot RETR. Let's try to apply RETR. Let's take the same list, okay, and then CV2 dot chain, and we'll try to take a simple, okay, and let's try to execute this code also. Now let's try to draw contours. Draw contours. Okay, so let's take mask fruit equal to CV2 dot draw contour. So before that we need to, before we just trying to other thing draw contours, let's go into the numpy, where we try to create a numpy with zeros for masking. Okay, so zeros for masking, right? Let's take masking for the fruit finger image. Okay, for same fruit finger image, let's try to do mask and the shape of the fruit finger. Okay, and then np dot uint8. Okay, and let's try to find the largest contour areas. This is again as we did it before. Okay, let's try to take cv2 dot okay, I think before largest contour, yeah, we need to do a sorting, right? So let's do a sorting, and um, contours, comma, key is equal to cv2 dot contour area, right? Okay, let's, now we have taken the mask and then try to find out the largest area of the contour. Okay, now let's try to draw the contour with this. Okay, so as this is mask, right, we need to find the mask, masking here. Next we try to do um, draw contour. Okay, so now here we'll just try to take the contours, and again for the contours, sorry, we need to, contours not required, right? Already we took the contours. Now we need to take masked contour with the above image, correct? Mask underscore fruit. Let's take as mask underscore fruit, and then cv2 dot draw contours, right? And let's take the mask fruit of the above one, right, which is mask fruit. Yeah, now we need to take the largest areas. Okay, the largest areas of -2. Okay, and then let's take it as 0, and these are all the same similar thing what we have done before. So you can do 255 come on 255 come on 255 come on 255. It can be 3 or it can be 4, both will work well. Okay, let's take it as -1. Okay, let's try to execute. I hope it works. Okay, right. Now let's try to visualize the image. Let's take the same image. Even you can create a function and then you can start doing that. Otherwise you can just copy paste it. But I would suggest using the function would be, our job would be much more easier. But I've used in this code just copy pasting it. So I leave it to your comfortability. How do you want to actually have it? Okay. So here now let's try to take the masked fruit. Masked fruit, right? So, and then the images is going to be the same. Let's take this, yes, this masked fruit that we are going to visualize it. Okay. Okay, now we got the fruit. Okay, now let's try to apply bitwise operation. Okay, which will help us to take out the apple with the color. Okay, because now the above one is the masked one. Let's try to apply that in our original image. Okay, so let's take, that's a fruit final that we will be taking. Fruit final, let's take that as a fruit final one. Okay, and then let's try to apply CV2 bitwise. What should we take? Let's take and. Okay, and then let's take the PLT image. We're going to apply on the PLT image. Okay, and then there would be a mask is equal to, what is the mask here? Yeah, this was a mask fruit. Let's take this as mask fruit, and then let's try to apply it here. Okay, now let's try to run the code. Let's see whether we could able to pick up the, the original image. um, Only apple, only with apple. Okay, now let's take the fruit, um, fruit final. Okay, and this should be a masked fruit. Okay, let's take this fruit final. Hope this works, and we are going to take 3 images, so we need to change it here. Let's see whether it works. Okay, now we got the final image, which has been extracted from the original image, which was the objective of this particular study. We had apple in the plate with a finger, right? We removed everything. Finally, we got an apple. We applied various techniques, and then we finally narrowed down to pick up only apple. Thank you. I hope you all have enjoyed this. Let's see in another video down the line. Please do like the video and try to share the videos, so that that gives more encouragement for us to proceed in more videos. Thank you so much, guys.